In order to find the formula of an ionic compound, we just went through a process where we looked at the electron structure and did a very cumbersome process to work out that sodium chloride is NaCl, a ratio of 1 to 1, 1 sodium per chloride. And we looked at the idea that magnesium, because to become stable it loses 2 electrons, and fluorine, to become stable it gains 1 electron, then you need 2 fluorine atoms for every magnesium atom. The magnesium will lose 2 electrons and become an Mg double positive ion. 2 fluoride ions will be formed because those electrons will go to 2 fluorine atoms. And it balances out, it becomes MgF2. So let's have a look at some of the things here that we can do without doing that, without doing all that business about drawing the electron structures, and work out what the formulae of some ionic compounds are. And before I start, you know that some things are metals and some things are non-metals. The elements that are metals tend to be in this area here, in the bottom left here. So we've got lithium and beryllium. They're like metals, but the beryllium sometimes doesn't act like it. Sodium's a metal, magnesium's a metal, and aluminum or aluminium is a metal. And what they tend to do, metals, tend to produce positive ions. And they produce positive ions because they have very few electrons in their outer energy level, very few valence electrons, and when they lose those, they lose negative charges. So they tend to have a positive charge. And you can see that really, really clearly on this periodic table. Let's just look at the metals for a moment. Although hydrogen acts in a similar way, and hydrogen being a very non-dense, a very rarefied gas, obviously it's not a metal, but in this way it acts similarly to a metal. So anything in group 1 has 1 electron in its outer energy level, and so it's likely to lose that electron, and it's likely to produce a single positive ion. So lithium, single positive ion. Hydrogen, single positive ion. It tends to lose that electron. Something over here is a non-metal. And let's look at the ones that actually do this. So I'll look at some of the common ones. Anything in group 7 tends to gain an electron to become stable, just like neon or argon in group 8. And so because they're going to gain an electron to become stable, they gain a negative charge and become minus. So fluorine becomes negative fluoride. Oxygen has 6 electrons in its outer energy level. This number here means how many electrons in the outer energy level. The only exception to that is helium. Helium, of course, does not have 8 electrons in its outer energy level. It has only 2, because it's only got 2 electrons. But because that's stable, and because that acts in the same way as neon, argon, xenon, radon, we've moved it over to group 8. There are reasons for putting it there, but it makes so much sense to put it there because it explains how helium acts in a chemical reaction. In other words, not at all, because it's stable and doesn't gain or lose electrons. So oxygen here needs to gain 2 electrons to fill its outer energy level and become stable, like neon. So here it is, gaining 2 electrons. Now it's got 8 protons and 10 electrons. So oxygen and anything in group 6 produces a double negative ion. Sulfur produces a double negative ion. And these negative ions gain the suffix "ide." So that's now an oxide ion. And here's a sulfide, double negative ion. All right, and you could take this back, but it doesn't happen as often. So this gaining 3 electrons and not being nitrogen anymore, but being nitride. And here, the same thing happening to make phosphide. And here we've got beryllium and magnesium. They lose 2 electrons. Because they lose 2 electrons, here's magnesium, 12 plus, 10 minus, because it lost 2, and it's magnesium double plus. You can write it with 2 pluses if you like. Our textbook does that, so I'll stick to that from now. And beryllium, of course, 2 pluses. And aluminum, or aluminium here, with 3 outer electrons. It's in group 3, so it must have 3 outer electrons, tends to lose those 3 and become 3 plus. So let's have a look at the formulae when we put these together. So sodium chloride, sodium, 1 plus. Chloride, 1 minus. They balance. We don't do anything else. Let's see. Sodium oxide. Oh, it doesn't balance. We need to balance the charges, otherwise it's not a stable compound. We need another positive. We need another sodium. That's what we do. Notice we're only putting small subscript numbers to the right. Let's try aluminum, 3 plus, because it loses 3 electrons, and chloride, which has gained 1 electron. But here we've got the situation where, oh dear, 3 pluses and 1 minus. So we need a ratio of 3 minuses to 3 pluses. They need to even out. And this is basically how you write the formulae for ionic compounds.